Okay, so now we're actually ready to get to the main event here. So what I've created for each one of you are basically, we're going to do for the competency 4 problems. They're going to be 4 problems that we're going to do. The first one are actually the first 3 columns. If you look at the first 3 columns, what does it look like that comes from? Alexis, what does that look like that is actually coming from as far as the articles we read? Does it look a little familiar at all?
Yes, it looks like the article on the marriage.
Yeah.
And divorce.
This is the article. I created a data set based on the marriage and divorce. So if you want to write a few notes on it, what I've created here is a data set where in the first column, it's the years of marriage. Now, I've just made this up. The years of marriage. Column 2 is the negativity. Maybe during the first year, the negativity. And column 3 is the happiness on the wedding day. Now, Beverly, do you remember reading the articles in terms of which of these variables might be important in terms of years of marriage?
The negativity one.
Yeah, the negativity. It's kind of how the husband and wife, same to you, the sarcasm, the contempt, all those negative things, that they seem to be predictive of years of marriage. What about happiness on the wedding day? Is that predictive of marriage stability? From the article?
I don't remember that in the article.
Yeah, they measured that, but not on the wedding day, but in the first year is what they did. But I created just on the wedding day. Was that related, Emily, to the long-term stability of the marriage? How happy the couples were when they got married? Don't remember? It's okay. It wasn't really related very much to the whole equation. So what we're going to do on this data set, what do you think the right analysis would be here? Beverly, what do you think the right analysis for this would actually be in terms of statistics?
Probably an ANOVA.
It wouldn't quite be the ANOVA here, because for the ANOVA, you need kind of categorical independent variables. Emily, do you remember what kind of analysis would be appropriate here? In the Gottman article, what kind of statistics did they do there? Don't remember? Alexis, do you recall? This is going to be a regression situation. This is going to be a regression, if you want to write that for the notes. This will be a regression situation because we're interested to know what. What are we going to try to do here with this data set? We want to know...
We want to predict.
We want to be able to see if we can predict the years of marriage from what, Miss Emily? We can predict the years of marriage from what?
We want to see if we can predict the
years of marriage.
The years of
marriage. Alexis, from what?
Based on negativity and happiness of the...
Yeah. We want to see if the 2 predictor variables, happiness on the wedding day as well as negativity during the first year, we want to see if they can predict years of marriage. The other important thing... We want to see if negativity and happiness can predict the years of marriage. The other very important thing...
We want to see if we can predict the years of marriage from...
Negativity and wedding day happiness. The other important thing to note here is that the variables here are all continuous, right? They're all continuous variables. They're in a range. That's why we couldn't actually do an ANOVA so much on this, because we have continuous variables. So if it's a prediction situation, we would actually do multiple regression here. We could also throw in probably some correlations here as well. Actually, let's do that as well. We're going to put in some correlations here. Beverly, is this working for you? Okay, so let's actually go and do the steps. So for if you wanted to run the correlations first, how would you do that? What would you do?
Analyze.
Analyze?
Correlate.
Correlate. Let's just do analyze and correlate. Bivariate.
Alright, I gotta write that down.
Yep. Bivariate. It's good to write that in. Now notice it has all 4 of the data sets, but which variables do you want to put in there?
Years of marriage, negativity, and wedding happiness.
Yep, just put in the 3, don't put in the 10. So you put in the 3 variables, and then what do?
Click OK.
Click OK. That saves you about an hour. So click it on OK. All right. And actually, this might be a perfect example.
Why are we doing correlations when it's regression?
Well, you do correlations first and many times regression, so I'm just kind of adding that in. This is a very simple situation, though. How does that data look? Beverly, does it look like there's anything interesting there?
It looks like the
Looks like
the wedding day happiness doesn't
Yeah.
have significant effect on years of marriage.
You're good, you're good. Yeah, Drew just came in. If you want to sit next to Alexis and kind of look on her screen, that would be good. Yeah, if you look at the data, the important information, and actually, why don't we show you guys how to actually put this in a Word file. So for Alexis and for Emily, go into the bottom screen and go into Word. Open up just a Word file. Go into Word. Does it allow you to do that? Is there Word anywhere there? No. Wrong one. See if you can you get into a Word file? Go 13, Word 13. Can you show Alexis how you did that? Oh my Lord, what the heck?
There's Microsoft Word 2010.
Try that one.
It doesn't have that one on.
Go
Oh,
13.
okay.
We're just trying to open Word here and it's turning into...
You can just double click.
Okay. So what you want to do is go back to the output screen that you were on. Do a... go into Edit on the top. And actually, you can just... I think it's a copy command.
Yeah.
Just Control C. So highlight the window and do copy. And then go into Word and do paste. That's it. Why don't you save your Word file here? Let's see. We might catch you up at after this one. Okay, Drew? Just watch out for now. Why don't you save that file that you just did? Because you'll be adding lots of things during the course of the proceedings today.
Save it on the desktop.
Yeah, just save it on the desktop for now.
Alexis 2.
Sure. Okay, so let's go, and actually, this could be useful for typing notes right in here.
Okay.
So from this screen, Drew, what we've actually done here is we created a data set, or I gave the class a data set that actually showed in the information. Actually, why don't you go back to the data screen? We'll show them what we created. Able to go, yeah, there it is. Created a data set, years of marriage, negativity, and wedding day happiness, and we started by just running correlations on this. And then we looked at the correlation output screen, and we were just trying to go over what the correlation output screen had on it. And the important line, and you can go back to even your Word file now, because you could even take notes on this, it's the top row that matters. So that first correlation, you see where it says years of marriage and years of marriage 1? That means nothing. That's correlating Years of marriage with years of marriage. It's the same numbers. That'll always be 1. The other 2 numbers are what's really important. Look at that negativity number. Beverly, how is that negativity number?
It's statistically significant at the .01 level.
Yeah, it's statistically significant. And so that's going to be very
What
important
is?
to us. The negativity versus years of marriage. The negativity versus the years of marriage. Drew, if you even want to open up a Word file, you can certainly type some of this stuff in.
Is statistically
it working?
significant.
There it
Is
goes.
that a correct statement right there?
Yep, it was significant. So the correlation here is negative 0.943, because I made the data set up. So I knew it would be. It took a few minutes. Kept changing my numbers. So what is the real world on that? What does that say? Alexis, what does that say?
First year, the amount of negativity in marriage, more likely to divorce.
Yeah, that there's a correlation exactly. As negativity in the first year increases, marriage length decreases. So as negativity in the first year is higher, length of marriage is shorter. As negativity during the first year increases, length of marriage decreases. As this variable goes up, that variable goes down. Emily, does that make sense for you?
Yeah.
Have you guys seen this in relationships? Either your own or other people you know?
Yes.
Yes. Beverly, I hear a little giggling there. Is it that way for you or people? In psychology, we always say I have a friend that happens to, right?
Yeah.
Do-
Yep.
Are we doing R equals?
Yeah, and the APA statement. Let's figure out the APA statement here. So it would be the letter R. And then what would be in parentheses here? Correlation. N minus what?
Is it minus 1 or 2?
It's a correlation. So what would it be? N minus 1 or N minus 2? Correlations are based on a straight line. N minus 2. N minus 2. So it'd be R 8. Be R and then be 8. Little r. Big R means something else. R 8 equals what?
.94.
Negative 0.943. The sign is very important here, isn't it? And then what? Comma.
P less
Less than what?
than .00.
Yep, P less than 001. Is that working?
Sorry.
So this is as predicted, right? Okay. Done with that? Save that file? Beverly, is that working for you?
Mhm.
Okay, let's go back to our data set. Because now we need to do the next step. After we run the correlations, what's the next step here? We said we were doing correlations first. Oh,
Regression.
and the regression, actually we forgot one here. Let's go back to the Word file. The other thing you'd want to know is what about happiness on wedding day? Was happiness on wedding day correlated with years of marriage? No. So we want to write a statement about that. Correlations, or you could say, wedding day happiness was not related to the years of marriage. Notice it's very important here on the screen. Notice that the correlation was what? What was the correlation between wedding day happiness and years of marriage? What was the correlation?
Negative 0.001.
001. Hey, wait, we're significant. What's wrong with my statement? Is that significant?
No.
Why not? It's not the probability, that's the correlation. What does it tell you the probability is of getting that? Due to chance. Does it say like 98% or something right below it? Don't confuse correlations and significance. That's a terrible correlation. There is no relationship. So we would write that out of what? R,
R
then what?
A
8, little r, equals
Negative 0.001.
negative, 0.001. Then what would you write?
P is greater than 0.05.
There you go. P greater than 0.05. Okay. Save that as well. Now let's
P
actually go
greater
into the
than.
next. What's that, Em?
P greater than.
Yep, greater than. That's right. Let's go back to the data set then. What was the next step in our process? Once we do the correlations, what would we want to do next?
Regression.
We'd want to do regression. What I'm going to show you how to do here, and you'll want to write a few notes on this, is a special type of regression. I'm going to show you, and you want to write some, actually, we've been babbling on for a bit here.